Hey guys, good morning. I will assume that you're watching this video at like 8:30 in the morning or something like that. No? So today we're gonna go over chapter 5. It's about constraint management. So before we start, this is very important. We're getting closer and closer to our assignments. So remember, you can do my lab assignment up to one day before your midterm exam. Okay, it's open, it's available. We have chapter break even, chapter 2, 3, and 4 are all available for you. And now I'm gonna put chapter 5 as well. You can do it now, you can start, or you can do it closer to the midterm, but they're getting closer and closer. Okay, don't forget about that. And also, we're getting closer to the team assignments, and that's coming, so you need to start reviewing the material that we had in class. You have one that's going to cover everything from the beginning until chapter 3, and yet one chapter 4, 5, and 6. So be mindful that you need to review those topics. We're going to talk about constraint management. So what is a constraint? What do you guys understand as a constraint? Constraint, as the name already say, is something that limits, right? In our case, it will limit the capacity of a process. So we looked at overall capacity, right? Chapter 4. Now we're going to look in depth into the process steps and find out what limits, what makes the capacity be that number, right? And how can we improve capacity of a process to actually be able to produce more parts. So a constraint is also known as a bottleneck, okay? And there's a little bit different concepts there, right? So let's take a look at a bottle, right? So I brought one for you guys just to take a look. That's our experiment now. So it has a little bit of water, right? And if I turn upside down, what's going to happen? Not going to do it. I'm not going to make a mess in the middle of my office here and my laptop and everything, right? But if it were in class, I would. If I open the cap here, right, the water will flow. But what will be the flow of the water? It will depend on the size of the bottleneck, right? It will be this size, right? That's going to be the flow of the water. What happens if I take the same water, same amount of water, same bottle, same amount of water, and I cut it here, and go upside down? Okay, so what I'm doing then, do you think the flow will be higher or lower? Will it empty faster? Yeah, a lot faster, right? In 1 second, it'd be all over and it'd be a mess, right? Uh, because what I did was I got rid of the bottleneck. And when you get rid of the bottleneck, you expand the capacity of the process. In this case, we're looking at how much flow I can get out of the bottled water. So I expanded that because this was limiting the whole system. So remember that, this being big doesn't mean anything because the whole system is constrained by this size. This is the size that will define the flow of the water. So it doesn't matter if I have a lot of capacity on these processes here. So think this about several processes one after the other. The production and the flow of my production system will be limited by this bottleneck. This is going to be my production flow. Okay, I cannot produce more than this flow here, right? Because, the slowest process in this case, the one that will constrain the capacity of the whole system. Does that make sense? And then we have these couple of concepts here. So a bottleneck is the slowest process, right? And most of the time we'll present it as cycle time or capacity, the process, right? So the slowest cycle time is the bottleneck. It will limit the production of the whole system. Okay, and you have other constraints and other limitations. So let's go back to examples of a classroom, right? So imagine that you're inside a classroom, 60 seats we have there. What are the constraints of a classroom? So we have the size, the technology, and the faculty, basically, right? And then what is the bottleneck, right? What's limiting us to only have 60 students in the classroom? Is that me? I can teach only 60 students, 61 students that say, nope, I give up. No, that's not it, right? It's the technology. No. A classroom, a projector, you can project for more people. It is the size of the room, right, that actually limits, but it's not limited only by the size because we can put a lot more people in that room if we wanted to. It is the fire hazards that limits our room to 60 people. And now we have another constraint, which is the social distancing happening, right? So you even constrain that more to 30 people, right? So these are limitations to our process, right? I'm not the constraint here. I can teach for more people. The constraint is going to be the social distance plus fire hazards in limitations, right?